Hello students, welcome to Auja classes Smartness in Education. This is the second part on fluid mechanics in which we are going to discuss about viscosity and the types of fluids. Viscosity is a property of a fluid which offers resistance to the movement of one layer of fluid over the another adjacent layer of the fluid. That means one layer when the fluid flows or when it is stationary, the different layers of fluid offers resistance to their adjacent layers. This resistance is basically developed just because of the shear stress developed between the two layers of the fluids. Let us see in this diagram the highly viscous fluid can fill the container very slowly, but the low viscous fluid can fill the container rapidly as compared to the viscous fluid. So, in low viscosity, the flow is comparatively easier than the higher viscous fluids. Now, the mathematical expression for viscosity. Viscosity was mathematically first of all expressed by the Newtons, and he gave a law for the viscosity which is known as Newton's law of viscosity, according to which, see this diagram, in this there are different layers are between two plates. First plate is stationary and another plate is the moving plate, and here the in between these two plates, a fluid is present. Let the shear stress between two adjacent layers of fluids is tau, and the velocity gradient means, suppose this length is dy and the change in velocity is du between these two layers, and the upper layer can flow faster than the lower layer. So the difference in velocity of two adjacent layers is du, and the difference in level of two layers is dy, and hence the velocity gradient will be du by dy or del u by dy if it is the partial derivative. So the mathematical representation of Newton's law of viscosity is tau or shear stress is directly proportional to the velocity gradient or the shear strain. This velocity gradient is also known as shear strain. Now, if we remove the sign of proportionality, then we get tau equals to mu into du by dy, where mu is a constant of proportionality and is called viscosity of fluid. So, and this is the viscous coefficient. So, viscosity can be determined by tau upon du by dy. That means shear stress upon velocity gradient or shear strain. Now, now let us talk about the units of viscosity. Viscosity is represented as mu equals to tau upon du by dy, where tau is the shear stress and du by dy is the velocity gradient. So mu can be written as shear stress is given by tangential force per unit surface area to which the stress is being acted, and velocity gradient, velocity is measured, velocity gradient. So velocity gradient is measured as velocity per unit length. Now force is measured in Newton, surface area is measured in meter square, velocity is measured in meter per second, and upon length again it is 1 upon meters. So this has been cancelled out and you get mu equals to Newton second per meter square. So in SI system, the unit of measurement of viscosity is Newton second per meter square. One more common unit of viscosity is poise, which is 1/10 of the Newton second per meter square. This is also commonly used in our textbooks. Kinematic viscosity. Kinematic viscosity is basically independent of mass or mass density and it is basically represented by the symbol nu, and it is given by the ratio of dynamic viscosity with respect to the mass density of the fluid. Mu represents the dynamic viscosity and rho represents the mass density of fluid. Now, if we talk about unit of kinematic viscosity, then we get Newton second. We have dynamic viscosity as Newton second per meter square, and mass density is given by mass per unit volume, and therefore kinematic viscosity can be written as mu equals to Newton second meter per kilogram or Newton meter second per kilogram. And now if we convert Newton into more say fundamental units, then we get 1 Newton is what? Mass into acceleration. So Newton is kilogram into meter per second square into second per meter and upon kilogram. So we get the viscosity, kinematic viscosity as meter square per second. Now, if we convert the kinematic viscosity into CGS system, then we get 100 centimeter square upon second, and that means this is 100 square centimeter square per second. So we get 1 centimeter square per second as 1 upon 100 square nu, or 1 centimeter square per second as 10 raised to power minus 4 meter square per second, and hence it is called 1 stroke. 1 stroke. So we can write 1 stroke as 1 centimeter square per second. Let us talk about types of fluids. Fluids are fundamentally of the following 5 types. The first type is the ideal fluid, in which there is no shear stress. Second one is the Newtonian fluid, in which the shear stress is directly proportional to the velocity gradient, or the fluids which follow the Newton's law of viscosity. Second one is non-Newtonian fluids, in which the shear stress is not directly proportional to the non-Newtonian, not proportional to the velocity gradient. Next one is ideal plastic fluid, in which there is initially some kind of stresses already present, and the next is the ideal solid, in which there is no velocity gradient or velocity strain. Let us talk about these kinds of fluids in detail. A fluid basically which is incompressible, which cannot be compressed, means whose density is constant and which has no viscosity, is called ideal fluid. Now, all the other fluids which are not ideal are known as real fluid. In practice, there is no ideal fluid is present in practical life, and all the fluids are basically real. Next is Newtonian fluids, in which the shear stress is directly proportional to the shear strain. That means the fluids which obey Newton's law of viscosity. Therefore, they are known as Newtonian fluids. Now, non-Newtonian fluids means which do not obey Newton's law of viscosity, and in these fluids the shear stress is not proportional to the shear strain or the velocity gradient. Ideal plastic fluids are the fluids in which the shear stress is basically more than the yield value. That means initially a particular shear stress is already present in these kinds of fluids. Shear stress is proportional to the rate of shear strain or velocity gradient, and hence they are known as ideal plastic fluids. Thank you. In the next lectures, we will discuss about some problems based on the viscosity. Thank you.